Life on Mars, Challenges and Solutions. Mars, the red planet, has inspired humanity for centuries. The possibility of living on Mars presents one of the most audacious challenges in human history, a dream that combines scientific ingenuity, resourcefulness, and a desire to venture beyond our planetary boundaries. But what does it take to turn this ambition into reality? In this video, we'll explore the challenges of living on Mars and the groundbreaking solutions engineers and scientists are working on to make a Martian colony possible. Let's journey to the red planet and uncover the obstacles, solutions, and ultimate possibilities of life on Mars. Of all the planets in our solar system, why has Mars become the focal point of human exploration? Its relatively close proximity to Earth places it within reach of robotic and soon human missions. Unlike other planets, Mars shares some critical similarities with Earth, including a rotational day that's only slightly longer than ours and the presence of polar ice caps. Most importantly, exploring Mars presents an incredible opportunity to search for evidence of past or even present life while inspiring humanity to become an interplanetary species. Despite the allure of Mars, it is a planet fraught with danger and difficulty. The challenges of living there would push even the best minds and technologies to their limits. Mars is an unforgiving environment. With temperatures averaging -80 degrees Fahrenheit, -60 degrees Celsius, surviving without substantial protection is impossible. Unlike Earth, Mars has a thin atmosphere made up almost entirely of carbon dioxide, which provides no breathable oxygen and no significant buffer against the sun's harmful radiation. In addition, the lack of a protective magnetic field results in high levels of radiation from cosmic rays and solar particles, lethal exposure for humans over long durations. While Earth is abundant in liquid water, Mars is bone dry on its surface. Although scientists have identified ice deposits at its polar caps and underground, accessing these resources will be a significant challenge. Without a plentiful water supply, essential activities like drinking, farming, and producing oxygen or rocket fuel would be unfeasible. Mars is infamous for its dust storms, some of which last for entire months and span the entire planet. These storms can block sunlight, crippling solar-powered equipment, and coat machinery with fine, abrasive dust. This introduces a new layer of difficulty for maintaining both energy resources and advanced technology. Humans traveling and settling on Mars would endure months of isolation during the journey, followed by living in confined environments with limited interaction. The psychological toll of such confinement combined with the stress of an alien environment could pose a major challenge. Additionally, the reduced gravity on Mars, just 38% of Earth's, could affect long-term muscle and bone health. Despite these overwhelming challenges, human ingenuity is paving the way forward with innovative solutions that make it possible to imagine life on Mars. Building a livable habitat is one of the first steps to surviving on Mars. Engineers are designing shelters capable of withstanding the planet's harsh climate and radiation exposure. One promising idea involves creating habitats from Martian soil, or regolith, which can be compacted and used as a shield against radiation. Underground habitats could also offer natural protection from radiation and extreme surface temperatures. By taking cues from nature and using in situ resources, we could reduce dependency on supplies from Earth. One of the fundamental requirements for survival is breathable air. Recent test missions have included the MOXIE, Mars Oxygen In Situ Resource Utilization Experiment payload, designed to convert carbon dioxide in the Martian atmosphere into oxygen. Although still in its early stages, this technology could one day support full-scale oxygen generation for sustaining human life and powering rocket propellants necessary for return missions. Though extracting and conserving water will be critical for survival, technologies capable of melting and purifying Martian ice deposits are being developed. Additionally, innovations in water recycling, already being used aboard the International Space Station, ISS, could efficiently sustain astronauts. Mars soil, with its toxic perchlorets, makes traditional agriculture unfeasible. Instead, scientists are working on controlled environment systems like hydroponics, where crops are grown in nutrient-rich water rather than soil. Greenhouses with advanced climate controls could replicate Earth-like conditions to grow food. Experiments have also demonstrated that certain plant species can grow in simulated Martian soil when its composition is adjusted. Such breakthroughs bring humanity closer to achieving self-sufficiency on Mars. Meeting Mars' energy demands will require creative solutions. Solar power is an obvious choice because of its renewable nature, but its effectiveness is reduced during dust storms. As a result, nuclear energy is being considered as an alternative, providing a consistent, long-lasting source of power for habitats, vehicles, and life support systems. Integrating hybrid systems that combine solar, nuclear, and energy storage solutions may offer the necessary reliability for surviving Mars' environmental extremes. Protecting future Martian settlers from harmful cosmic rays and solar radiation is non-negotiable. In addition to shielding habitats with Martian regolith or building underground, scientists are exploring the use of hydrogen-rich materials for their radiation-absorbing properties. Innovations in protective suits would also provide portable shielding for astronauts working on the surface. Could humanity take even bolder steps toward making Mars more like Earth? Terraforming, the process of transforming a planet's environmental conditions to support human life, remains largely theoretical, but offers a glimpse into a far future solution. One idea involves releasing carbon dioxide trapped in Mars's soil and polar ice to thicken the atmosphere, potentially warming the planet and triggering a greenhouse effect. However, scientists currently lack the technology and resources for such an undertaking, leaving terraforming as a long-term dream rather than an immediate solution. The progress made by space agencies and private companies like NASA and SpaceX demonstrates that the journey to Mars isn't science fiction anymore. SpaceX's reusable Starship prototype, for example, is specifically envisioned to support human missions to Mars. Such technologies are rapidly improving the feasibility of Mars colonization. Additionally, robotic missions are paving the way, sending back critical data about Mars' environment and terrain while testing tools that will be integral for future manned missions. The truth is, Mars may only be the beginning. Establishing a sustainable presence on Mars could open pathways to exploring further destinations, like the moons of Jupiter or Saturn. Each new milestone would expand our understanding of the universe and solidify humanity's role as an interplanetary species. Mars colonization is not just about escaping earthly challenges. It's about inspiring innovation, fostering collaboration, and pushing the limits of human ingenuity. Each step forward brings with it solutions that have the potential to solve Earth-based problems, from advanced agriculture systems to efficient renewable energy technologies. Mars represents our ability to dream big and take risks to explore the unknown. By venturing to the red planet, humanity is embracing a future where possibilities are as boundless as the stars above. If the idea of embarking on this incredible journey inspires you, stay curious and continue to fuel your passion for space exploration. Don't forget to like this video and subscribe to our channel for more content that explores the wonders of our universe. Together we'll discover not only the mysteries of Mars, but the potential within ourselves to achieve the extraordinary. The red planet awaits. Are you ready to take the first step?